Alright, so in this video we're going to discuss briefly power and resistors. So the first relationship I've written up here is the power input into a pure resistor. So that power is going to equal the potential across the resistance times its current. And so summing in Ohm's law, we can also get that power equals I squared R, or that it equals the potential difference squared divided by the resistance. So if we're looking at the power output of a source, that power is going to equal the EMF times the current, minus the power dissipated across the internal resistance of the source. So when we're looking for energy loss, so the rate at which energy is lost because of the internal resistance of the power supply, we're looking for this I squared little r term. So little r, remember, is internal resistance of the source. So this is the rate at which work is done on the charges. This is the rate at which energy is lost because of internal resistance. And if we have power input into a source, we flip the sign here because now there's work being done on the battery rather than the battery doing the work. So the flow is in the opposite direction. So this is why whenever you charge your battery, it often feels warm, because essentially that energy from the what normally would have been heat loss is going back into the battery.